Okay, so welcome to part 2. So earlier we have already described the similarities and differences of liquids and gases. So now let us proceed to dimensions, units, and resources. So let us define what is a dimensions. So dimensions is a category that represents a physical quantity, such as mass, so length, time, momentum, force, acceleration, and energy. To simplify matters, engineers express dimensions using a limited set that are called primary dimensions. So if there is a primary dimension, so there's also a secondary dimension, so such as momentum and energy can be related to primary dimensions by using equations. So this will be elaborated more on the next slide. So table 1.2 lists one common set of primary dimensions. So in here, as you can see, we have these dimensions here: the length, the mass, time, temperature, the electric current, the amount of light, amount of matter. So these are the normal symbols for those dimensions. So L for length, M for mass, P for time, theta for temperature, I for current, amount of light is C, and amount of matter is N. So in SI unit, so we denote length as meter. Okay, so meter. Sometimes kilogram for mass. Then second for time, Kelvin for temperature, ampere for current, candela for amount of light, and amount of matter is mole. So those are just some of or these are the common sets only for primary dimensions. So for secondary dimension, this one is the common example for secondary dimension, which is the force, which is expressed in primary dimensions using the second or the Newton's second law of motion, which is F is equal to mass times acceleration. So primary dimensions of acceleration are L over t squared, or meaning this is the length over time squared. So you can see here in the equation, force is equal to mass times acceleration is equal to this M here denotes for mass. Okay, so that is a symbol for mass here. Then for acceleration, we all know that acceleration has this dimension here. This is the length over time squared. Okay, or to simplify, that is ml over t squared. So this is one of the common example for secondary dimension. Okay, so what is a units? Okay, so while a dimension expresses a specific type of physical quantity, a unit assigns a number so that the dimension can be measured. Okay, so that's the purpose of having a unit. So for example, measurement of volume. So our dimension here is the volume, and can be expressed using units of liters. So there are more units for that. I think cubic meter or cc, or this is also cubic centimeter, or etc. So it depends on the problem. Similarly, there's also another example here, a dimension, which is the energy. So this is here energy, and can be expressed using units of joules. Okay, so to have a specific unit, so we have these unit systems. So in practice, there are several unit systems in use. So the most common unit system that we're being used is the International System of Units, abbreviated as SI. So SI. So from the French, le système international the units. So it's based on the meter. Okay, so meter, kilogram, and second. So another unit system is unit or US customary system or USCS. So sometimes called as English engineering system or English unit to simplify. So it uses pound. Okay, so pound mass. So or LBM, that is for mass. Then for length, they use foot. Okay, so normally in some uses inches also for length for USCS. So pound force or LBF for force, and second for time. Okay, so we must be careful about this pound. I think in the subject dynamics, so we must be careful about this pounds here. Okay, so sometimes it is quite confusing if that given pound in dynamics is either pound force or pound mass or pound force. Okay, but anyway, so those are just basic examples for English unit or US customary system. So we also have this British gravitational or BG system, is similar to USCS system, that the unit of mass is slug. Okay, so to convert between pounds mass and kilogram or slug, so these are the common relationship for that. So 1 pound mass is equal to 1 over 2.2 kilogram, which is equal to 1 over 32.2 slug. Okay, so that is only for mass. So how about for length or for time? So I think there you should consider USCS because of their similarity. So for simplicity, so this text uses two categories for units. So the first category is the familiar SI unit system. The second category contains units from both USCS and the BG system of units, and is called the traditional unit system. Okay, so those are the two categories which will be used later as we go along with our topics. So we will be using both SI and USCS units to solve problems in fluid mechanics. So this is end of part 2